All right, let's look at, see what you can remember how to do this one. So this is on page 901, and this is number 49. Okay, it looks like this. Okay. All right, so the direction is going to say simplify, and then make sure that your final answer, the exponents are positive. All right, so what would be one approach you would take here? And remember your rules. Knowing your rules helps you with this. What rule do you think you would use first here? Power of a product. All right, so power of a product. Because I have a power and I have a product. So power of a product. And so what you want to do next is take each of these factors and raise it to that power. So in other words, I have a to the negative fifth raised to negative 6 times b squared raised to negative 6. Right, so remember, I went to go from here to here. I used the power of a product. Okay, now what rule do you think you'll use next? The power rule. So use a power rule. So when you have a power raised to power, what do you do those exponents? Multiply. So that's going to be a to what power? 30th times b to what power? Negative 12. So I go from here to here. I use the power rule. Okay, now is that the answer you'll give me? Why not?
Because it's got a negative exponent.
Because it has negative exponent. All right, so what rule are you going to use next?
A negative exponent rule.
The negative exponent rule. All right, so if you want to do that next step, you can, or you can go directly to the answer, but the next step would be this. You would say a to the 30th times, and then what's b to negative 12 the same as?
1 over b12.
Good. And so therefore, what's the answer you would give? Remember, you got to write as one fraction. A to the 30th divided by
b12.
b to the 12th. Okay. All right. So you remember a little bit more now than you did last time when I was asking questions. All right, let's look at all right, 61. All right, 61, you have something that looks like this. All right, that's what 61 looks like. Okay, so what would you do? What rule would you use?
Never mind. I'm going to do it. I got excited.
Well, you at some point you will, but what's the first rule you're going to use first? Power of a quotient. Power of a quotient. So you have a quotient and you're raising it up power. So the next step would be that you would say, well, then I'm going to take the numerator and raise it to that power. And then I'm going to take the denominator and raise it to that power. Okay? So to go from here to here, I use the power of a quotient rule. So the power of a quotient rule says you're going to take the numerator, raise it to that exponent, and then take the denominator, raise it to that exponent. Now, if you look at the numerator, what rule are you going to use next to simplify the numerator? Power of a product. The same thing with the denominator, right? So now I'm going to use the power of a product rule. All right, so remember, the power of a product rule says you take each of those factors and raise it to that exponent. So in other words, the numerator is going to look like this, just like number 49. You're going to do just like 49. So you're going to have a to the negative fifth raised to negative 4 times b raised to the negative 4. The denominator is going to be a raised to negative 4 times b cubed raised to negative 4. So the power of product, I'm taking each of those factors and I'm raising it to that outer exponent. Now, how do I get rid of the parentheses, or how do I simplify this even further? What rule? Power rule. So what is a to negative fifth raised to negative 4? A to the 20th times. Now remember this, that b that's inside the parentheses, what is that exponent understood to be? 1. All right, so when I use a power rule, 1 times negative 4 is a... No. 1 times negative 4. All right, so b to negative 4 divided by... Now, in the denominator, that a that's in parentheses, what is that exponent understood to be right here?
Positive 1.
Positive 1. Remember, the power rule says when you have a power raised to power, you multiply those exponents. So that's going to be a to what power? Negative 4. And then b to what power? Negative 12. All right, so remember I used the power rule here. All right, so that's where I'm at. Now, what rule do you think you're going to use next?
Negative exponent.
Well, you could, but if you use negative exponent, how would you rewrite it? I'm just curious. I mean, you could go that path.
Wait,
How would you rewrite if you were going to use the negative exponent rule? Just tell me.
A12, so B over,
A to the 20th.
and then B to the 4th power.
That's not b to the 4th. That's b to the negative 4th.
But you do the 1 on, I'm saying it right in my head, but it's 1 over B to the 4th.
Okay, so how would you write this one? All right, so she's saying this. She's saying she wants me to write this. So I'm going to use another sheet of paper. So you're saying this is going to be a to the 20th times 1 over b to the 4th. Is that what you're saying?
And then you do the bottom like that.
Then you do the bottom. Okay, so that's going to be what?
A to the, 1 over A to the 4th. And then,
Times.
1 over B to the 12th.
Okay, so then this is what you have. But what are you going to do with this? How are you going to deal with that?
You do the divide by 1, or I don't know the correct terminology.
So like this?
Yes. Yeah.
All right, so then what are you going to do?
And you multiply your numerator, like the A20 times 1.
1, okay. And
And
then,
then 1,
okay, 1 times b to the 4th is b to the 4th divided by
the same thing.
1 times 1 is 1.
And then A4.
A to the 4th, b to the 12th.
And then you can do the subtraction now.
Subtraction?
Yeah,
How?
like your matching terms. I don't know what it's called. Oh, I forgot about that.
So
It's
what do
something,
you?
But I don't know the name of that. Yeah.
So what are you gonna do next?
You're gonna do A20 minus A4, and it's gonna give you A16.
No, it's not. So notice the path that was taken, and then at some point you got yourself into trouble. Okay,
That's how they do it.
you got yourself into trouble at this point. Now you could have gone a further ahead. What you should have done next. What she was saying was I'm dividing a to the 20 by a to the 4th. So I'm using a quotient rule.
Yeah.
So she's saying that's going to be a to the 16th. That's what she's saying this is going to be. All right. And it's not. It's going to be 8 to the 24th.
Oh, yeah.
So
Like
she's-
negative, yeah.
That's not a negative.
No, but when you add, like when you do the A20 minus, and because that's a negative, A4 is representing 1 over A4. I see why it's going to be A to the 24th.
Okay. Now that's not the approach I would have taken, because look how complicated it got. But what you could do next is this. You're dealing with the division problem, right? So I can take the fraction that's in the numerator, multiply by the reciprocal of the denominator. What's the reciprocal?
A4.
B12 divided by 1. And now look, a to the 20th times a to the 4th is what?
A20.
Times b to the 12th, right? Divided by b to what power?
B to the 4th.
Now use the quotient rule on this, so it's going to be a to the 24th times b to what power? The 8th. All right. Now, that's not what I really wanted you to do. When I asked you earlier at this point, when I asked you what approach are you going to take next, I was hoping that at least one of you would have said what? The quotient rule.
How do it
The quotient rule. Here. it is much simpler. So what is a to the 20th divided by a to the negative 4th? That's just a to the what? 20. But go ahead and tell me what you're going to do with those exponents. You're going to do what? Subtract. Yeah, you can skip this step. What I'm doing, you can skip that step. But for some of you, you might want to do that. I mean, you might want to write it. And then that's b to the, that's a 4, negative 4. And that's b to the negative 4, subtract a what? Negative 12. And then remember, if you don't remember your signed numbers, use your calculator. What is 20 subtract a negative 4? 24. What is negative 4 subtract a negative 12? That's negative 4 plus 12, which is what? 8. And so notice how much easier it is to have used a quotient rule first rather than doing the negative exponent rule. Okay? Yes, so remember at that point, you want to use the quotient rule. All right, so that was 61. And then finally, let's do one more. We're going to look at 67. Actually, let's do 69, sorry, 69. All right, 69, you have a to the 4th in the numerator. This is what it looks like. B to negative 7, and that's being raised to negative 5th power, divided by 5, a squared, b to negative 1st, and that's being raised to the negative 2nd power. All right. All right, how are you going to simplify this? What were you, power what? Product. So in the numerator, you're going to take each of those factors, you're going to raise it to that exponent. So in other words, it's going to look like this. You'll say a to the 4th raised to negative 5 times b to negative 7 raised to negative 5. Okay, now in the denominator, same thing, power of product. Now what's that first factor you see that's in the denominator? The 5. So it has to be raised to what power? Negative 2nd. What's the next one you see? It has to be raised to what power? Negative 2nd. What's the next one you see? It has to be raised to what power? Yeah. B to the negative 1 power. All right, so what I used here was power product rule. Okay, now at that point, how do you simplify it further? What rule? Power rule. Okay, so what's a to the 4th raised to the negative 5th power? Yes, so remember when you have a power raised to power, you multiply the exponents. B to what power? Positive 35 divided by. Now let's leave that coefficient alone for right now. Let's just leave it as a to negative 2 power. Yeah, I'm sorry, I didn't mean a, I meant 5. 5 negative 2nd power. All right, y'all agree that's this, correct? All right, we're going to come back and deal with this in a little while. A to what power? Negative 4. B to what power? 2nd, right? Negative 1 times a negative 2 is a positive 2. Okay, now at some point, what rule are you going to use next at some point? The quotient rule. But before we do that, let's just deal with that 5 to negative 2nd power. Now remember, what's this coefficient up here understood to be? 1. So let's think about this 1 over 5 to negative 2nd power. Deal with that first. What's 1 over 5 to negative 2nd power the same as? No, not 1 over 25. 1 over 5 squared is 1 over 25. How do I make that exponent positive right here? Where's that exponent negative? In the denominator. If I want to make it positive, where do I put it? Okay, so do y'all agree that this is going to be just 5 squared? And what's 5 squared? Now notice, where was that 5, when I did that 5 squared, where's it located? Numerator, denominator? No. 5 negative 2 is located in the denominator. Where's 5 squared located? Numerator. So in other words, this right here, I'm going to end up putting that 25 here. All right, so y'all agree I get 25. Not 1 over 25, but what? 25. All right, so you got to be careful with that number. All right, now let's use the quotient rule. So it can be a to the negative 20th, subtract a what? Negative 4. Times b to the 35th, subtract a what? 2. So that's where I'm at. All right, so it'll be 25 times a. Now, negative 20 subtract a negative 4 is negative 20 plus 4, which is negative 16. 35 subtract 2 is 33. All right, so that's where I'm at. Now, remember, the issue for some of you would have been that 25, that 1 over negative 5 to negative second power. Now, remember, make sure you understand where I got that 1 from that's here. That 1 was from the fact that this coefficient right here is what? 1. So that's where that came from. And so 1 over 5 to the negative second power is just 5 squared. Before we finish this, just kind of review this. What if you had this? That was one of the worksheets you had to turn in today. What if you had 3 over a to the negative 4th power? What's that answer? What would that be? 3a to the 4th. The only thing being raised to negative power is the a. So if I want that exponent to be positive, since it's located in the denominator, I've got to rewrite it where? In the numerator. So that's just 3a to the 4th. And then just kind of like if you had, let's say you had 3a to the negative 6, what would that be? 3 times 1 over a to the 6, which is just 3 over a to the 6. And then what if you had a to negative 7 divided by 2? What would that answer be, do you think? Now, he said 2 over a to the 7. Is that correct? No. What's the only thing being raised to the negative power? The a. Everything else stays where it is. So the 2 is going to stay where? In the denominator. The a to the negative 7, I'm going to bring it where? All right, so what's the numerator? 1, because that right here is understood to be a what? A 1. So the answer is 1 over 2a to the 7. Okay, yeah.
On the worksheet, we had one that was like p over something and to the exponent, and then pp to a negative exponent. I didn't know how to do that. Can we do an example like that one?
When I give out the keys, then let me know. Okay, so here, what's the only thing being raised to negative power? The a. Now, so everything else stays where it is. So if you want to do it in steps, so you'd say 25 times 1 over what? a to 16 times b to the 33rd, right? For some of you, you prefer to write as 25 over 1, which is fine, and then b to the 33rd divided by 1. And then remember, you multiply fractions, you multiply the numerators together, and then multiply the denominators together. So what's going to be the numerator? Yep, and then denominator is just a16. All right. Okay. All right. So part C I'm going to give today. So part C is going to involve this as well. Okay. All right. So let's talk about scientific notation. So we're going to finish up this section. This is section 12.2. Okay, now, many students, they get a little confused because when you do it scientific notation, it's just a matter of moving your decimal point, which has to do with multiples of 10. So they get a little confused in terms of what should that exponent be. Should it be negative or should it be positive when dealing with scientific notation? So what you may want to do is just remember the number 1,000. Just think of 1,000. All right, so you see you have that 1 and a lot of zeros, so that would be a multiple of 10. So 1,000 is just 10 to what power? The third. Okay, so 1,000 is 10 to the third. Now, do you also agree that I can write 1,000 as 1 times 10 to the third? Yes or no? Yeah, because 10 to the third is 1,000. 1,000 times 1 is what? 1,000. Okay? So notice when you're dealing with a whole number and you think of the decimal point, where's that decimal point understood to be? Right here, correct? At the end of that number. And so notice what I'm doing here. See how I have this 1? When I move this decimal point to the left, one place and another place, you're actually dealing with a power of 10. So notice I moved it 1 place, I moved it 2 places, and I moved it what? 3 places. All right. So when I moved it 3 places, there's a 1 in front of that decimal point. So I just moved the decimal point 3 places to the left. 3 places left. Students get confused because when they think that you're moving to the left, they think of that number line, and when you go to the left, you're going towards what numbers? Negative. And so they want to rewrite this as a -3. But if you think of 1,000 and you remember that 1,000 is just 1 times 10 to the third, then you know that to rewrite 1,000 as 1 times 10 to the third, we have to move the decimal point to the left, which means that the exponent has to be positive. Now, it kind of, well, I'm not going to go there. All right. So then when you have something like this, let's say 2,000, what do you think that would be? 2 times 10 to the third. So the decimal point's understood to be here. I'm going to move that decimal point all the way to the left where there's just 1 digit in front of the decimal point. And so how many places did I move it? 3. So you're going to say 2 times 10. Whenever you move the decimal point, you're dealing with the power of 10, whether it's a positive exponent or negative exponent. So it'll be 2 times 10, and then I moved it how many places? 3. So that'll be positive 3. It kind of makes sense because 10 to the third is 1,000. 1,000 times 2 is 2,000. Now this right here is called scientific notation. So scientific notation is going to look like this. It's going to be some number times 10 to a power. Some number times 10 to a power. That number, though, this number that you're looking at right here, if this is your decimal point, there can only be 1 digit in front of that decimal point. Now, let me rephrase that a little bit better, though. When I say that 1 digit, it has to be a non-zero number. So in other words, it cannot be a 0. That digit that's in front of the decimal point, how many digits must there be? Just 1. That digit that's in front of the decimal point cannot be a 0. It can be a 1, a 2, a 3, a 4, all the way to what? 9. It cannot be a 0. Okay, you can only have 1 digit. Okay? All right, so when we talk about scientific notation, we're going to come back to when you write something in scientific notation, what does it look like? All right, so here's the idea. Oh, and the power right here must be a whole number. I'm sorry, must be an integer, excuse me. Must be an integer. So integers, remember integers are like 1, 2, 3, 4, 5, and so on. 0, or -1, -2, -3, -4, -5, -6, and so on. So those are your integers. Okay, so let's look at this. It's not that difficult. Just remember 1,000. You get confused as to if you move to the left, move to the right, whether it's negative or positive, think of 1,000. So 1,000 is 1 times 10 to what power? A third. So when you move the decimal point to the left, the exponent has to be what? Positive. When you move the exponent to the left, the exponent has, when you move the decimal point to the left, your exponent has to be positive. So write this number in scientific notation. All right, so let's say this is my number. You have 2, 3, 4, 0, 0, 0, 0, 0, 0, 0. So the purpose of scientific notation is to write some numbers that have a lot of zeros in it, into a more compact form. So you see that a lot when you're dealing with science, especially astronomy. So like distance of planets and all that. So they're very, I mean, it could be millions and billions of miles. So you have a lot of zeros there. Okay. So where's that? Now this is not scientific notation because it doesn't have anything about times 10 to a power. Now that right here is called standard form. So the regular numbers you think of, the decimals, the whole numbers and all that, that's standard form. You want to write this though in, remember this is standard form right here. You want to write in scientific notation. You want to write in scientific notation. Okay, so where's that decimal point understood to be? You don't see it. Where's it understood to be? At the end. Okay, when I write something in scientific notation, that means I got to move the decimal point either to the left or the right, as long as there's how many digits in front of the decimal point in the end? Just one. Okay, so that means since it's at the end here, I got to move it which way? To the left. All right, now I'm going to move it to the left, and then where will I put that decimal point between what two digits? The 2 and the 3. All right, 2 and the 3. So I'm going to put it right here. So I'm going to put a little arrow there to indicate that that's where that decimal point is going to be. All right, now here's how you're going to write it, though. Okay, so you see, you're going to truncate all the remaining zeros. You're going to truncate all the remaining zeros. So you see how I'm circling all these, and those are all just zeros in the end? Whatever's at the end, if it's a string of zeros, you're going to truncate that. You're not going to put that in your answer, in other words. So this is going to be 2.34. You got to keep those digits, though. The 3 and the 4, you got to keep them. You can't just throw them away. 2.34 times 10, and I got to think of that power now. How many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So is that going to be a positive 9 or a negative 9? Positive. So there's your answer. 2.34 times 10 to the 9th. Okay, all those string of zeros, you don't put that in your answer. The whole purpose, remember, writing something in scientific notation is to get rid of a bunch of zeros to make it look a little bit better to deal with. So number 2, let's say you had 4, 0, 3, 6, 0, 0, 0, 0, 0, 0, 0, 0, 0. All right, so I want to write this number in scientific notation. So that's where you're going to have some decimal times 10 to a power. The decimal point's understood to be here. So I've got to move the decimal point between what two numbers? 4 and a 0. All right, now, remember we talked about truncating the zeros. Do I truncate this 0 that I'm pointing to? No, because you have a 3 behind it. You're going to truncate the zeros that appear at the end. So all these, see, that's a bunch of zeros, nothing, no other digit. So you're going to kind of, when you write your answer, you're going to take those away. So this is going to be 4.036 though, all right? And then the rest are zeros, so you can truncate those. Times 10, and then just count how many places you moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Okay, now, so you move the decimal point to the left, your exponent is what? Positive. All right, let's look at number 3. Suppose we had 0.000006. 0.00006. So that's a number that's a number that's less than 1. Y'all agree?
Yeah.
These numbers 1 and 2 are numbers that were bigger than what? 1. So your exponent would be positive. This is a number that's less than 1, so your exponent would be what? Negative. Now this time, the decimal is appearing on the left side, so I'm going to move it which way? To the right. Now remember, when you move it, can I move it between? When I move it, I'm going to ask you this: can I move it between the 0 and the 6 right here? No, because if you did, that would mean you have the 0 as your first digit. You can't have that. Remember, we talked about the fact that this digit in front of the decimal point has to be a number, one digit, but it cannot be what digit? 0. So you got to move it in front of the what? The 6. That's where you're going to move it. So then you're going to say, all right, now remember truncating your zeros. See that the first string of digits is zeros? So you're going to kind of like cross this out like this in your mind. And so the only non-zero digit you see that's over here is just what? 6. So it'll be 6 times 10. Now you get negative 6. 1, 2, 3, 4, 5, 6. Yep, negative 6. Okay? All right, now, you can always check yourself on the calculator with this. So you can always check and see if what you wrote is correct. So you're going to say 6 times 10 raised to the negative 6 power equal, and just make sure that what you see here is what you have here. Okay? All right, number 4. Suppose you had 0.000206. You want to write this in scientific notation. All right, now, you're going to move the decimal point, you're going to move it between what 2 digits? 2 and 0. 2 and a 0. Because remember, you can't move it between that 0 and this 2 right here, because that would mean that you have a 0 as your first digit. So you got to move it between 2 and a 0. And you're not going to move it. And you're not going to move it between the 0 and the 6. You can't do that because you would have how many digits in front of the decimal point? 2, because it would be 20.6. You see that? You can only have how many digits? Just 1. So then you're going to say, all right, so that can be 2.06. So you're going to, remember you truncate this, right? And you're going to keep the rest. Truncate, keep the rest. So you can say 2.06 times 10 to what power? Negative 4. And again, you can use your calculator to check this. 2.06 times 10 to the negative 4 equal, and you get this right here. All right? Okay, so that was going from standard form to scientific notation. Now we're going to go backwards. All right, so now direction is going to say write each number in standard form. Write each number in standard form. Now remember, the number I told you to remember is 1,000. So if you can remember 1,000, you should be okay. 1,000 is 1 times 10 to what power? Third. All right. So what we did in those 4 problems was we went from standard form to scientific notation. Now we're going to go backwards. Okay, we're going to go backwards. So let's think about how to go from this scientific notation to standard form. All right, so listen carefully. So we had 1 times 10 to the third, right? 1 times 10 to the third. That decimal, there's a decimal point, you just don't see it. That decimal point is understood to be right here. Okay? Now, remember though, I know that this is what number? 1,000. So to get those 3 zeros, I got to move the decimal point which way? To the right. Good. All right. So it's kind of like backwards than what we were doing. So to go from cyclic notation to, to go from standard form to cyclic notation, if you move your decimal point to the left, well, let me go ahead and do this one. To the left, your exponent was what? Positive. If you moved your exponent to the right, if you move that decimal point to the right, your exponent was negative. Going from scientific notation to standard form, since my exponent is positive, you're actually going to move the decimal point which way? To the right. All right, if this was negative, you'd move it to the left. All right, so let's look at this example. This will be number 5. So let's suppose we had 1.2 times 10 to the 5th power. 1.2 times 10 to the 5th power. And think about 10 to the 5th, or 10 to a positive power. If I multiply a number by 10, or by 10 squared, or by 10 cubed, or by 10 to the 4th, does that number become bigger or smaller? It becomes bigger. So that means I got to move the decimal point which way? To the right. So if you can remember that, you should be okay. So multiplying this decimal by either 10 or 10 squared or 10 cubed, that becomes a bigger number. So that means I can move the decimal point to the right. All right. So here's my decimal point is this. Here's where my decimal point is. I'm going to take that exponent. That's going to tell me how many places to move it. How many places do I move it? Which way? To the right. All right. So I have 1. You move to the right. So there's 1, 2, 3, 4, 5. See that? So 1, 2, 3, 4, 5. So you see where they have the little low end right here? These little low ends? You see what I'm talking about? There are how many of those? It's kind of like little valleys. There should be how many? 5. The first one is under which digit? 2. There's no numbers on the other, so what should I put there? Zeros. So it'll be 1, 2, and then how many zeros? 1, 2, 3, 4. So 1.2 times 10 to the 5th is what number? 120,000. And again, you have your calculator, so check it. So you'd say 1.2 times 10 to the 5th, and notice you get 120,000. 120,000. All right, 6. 2.07 times 10 to the 6th power. All right, so I will write this number in standard form. So it's in scientific notation right now, you'll put it in standard form. So that means I got to move the decimal point how many places? Which way? To the right. Okay, so notice though, so that means I got to add some zeros. Now the question is, do I add 6 zeros? No, because when I move it to the right, I've already taken up how many digits right here? 2. So that means I got how many digits left? 4. So that means I'm going to have how many zeros? 4. Good. So it'll be 2, 0, 7. How many zeros? 4. Good. All right. And so really that's what, 2,070,000? Okay. Number 7. Suppose you had 1.3 times 10 to the negative 4th power. All right, so if multiplying by 10 to a positive power moves it to the right, then multiplying by 10 to a negative number moves it to the left. And it kind of makes sense because isn't 10 to the negative 4th power 1 over 10 to the 4th? So you're actually dividing by 10. When you divide by 10, your number gets smaller. So you move your decimal point to the left. So here's my decimal point right here. I've got to move it how many places? Which way? To the left. So does that mean I'm going to be adding 4 zeros? No. No. because this already takes care of one of them. So I need how many zeros? 3. So it'll be decimal 1, 2, 3, 1, 3. See how that looks? So you move it 1 and then 3 more places. So move it 1 and then you need 3 more places or 3 zeros. Now normally though, we put a digit in front of the decimal points. What digit needs to be here? 0. All right, 8. Suppose you had 1.006 times 10 to the negative second power. So my exponent's negative, so that means I'm going to move the decimal point which way? Which way? To the left. How many places? 2. So that means I'm going to have to add how many zeros? 1, because I already took care of this 1 right here, this 1 digit. So it's going to be decimal. How many zeros do I need to write? 1, and then just write the rest. 1, 0, 0, 6, and just put the 0 in front. 9. Suppose you had 2.7 times 10 to the negative 7th power. Okay, my exponent's negative, so I'm going to move that decimal point which way? How many places? 7. 7, right? So how many zeros am I going to need though? 6. So you took care of this one. So I'm going to need decimal and then 6 zeros, right? 1, 2, 3, 4, 5, 6. Because notice this is what you're doing. You're saying 1, 2, 3, 4, 5, 6, 7, correct? That's what you're doing. So all these right here are going to be zeros. How many zeros are there? 6 of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Am I missing a 0? Yeah. 1, 2, 3, 4, 5, 6. I'm sorry, I was missing a 0 here. There should be how many zeros in between the decimal point and 6? Where am I getting that 6 from?
Wait, I don't know why you're that was your last zero. That was your last zero. 6.
Oh, okay. It looked like a 6 to me. And then I realized, well, where am I getting that 6? That's not a 6 right here. All right, so let's do this again. How many zeros do I need? 6. So we decimal 6 zeros, right? And then what are going to be right here? 2, 7. All right, good. That's bad when you can't even read your own handwriting. All right. Okay, now, you got to know this simple. I say simple because in a little while you can be multiplying these things, and it's not that bad. Okay. So let me kind of show you what the worksheet's going to look like to explain what it is I want you to write. So I'm going to give you the worksheet on the scientific notation. All right. Suppose I had these two numbers written in scientific notation: 2 times 10 to the 3rd power times 3 times 10 to the 4th power. Okay. All right. So there's a problem. Now here's the work I want to see. Now remember, when you multiply like bases, you do what those exponents? You add them. Okay, so they want you to use exponential rule. So that's where the power rule, the product rule, and all that comes into play here. So this 2 here, that coefficient right here, and this right here, the 3, you're going to put those together. Remember, all this is what operation? Multiplication. Now remember, when you read it as 2 times 10 to the 3rd times 3 times 10 to the 4th. And remember, multiplication is commutative. The order in which you multiply does not matter. So rather than saying 2 times 10 to the 3rd first, I can say 2 times what first? 3. So in parentheses, you're going to put the whole number parts, not the whole number parts, but the coefficient parts. And then you're going to put the base 10s together. So there's going to be 10 to the 3rd times 10 to the what? 4th. So that's what I want to see. Okay? And now what's 2 times 3? 6. And then times, you're going to put this in scientific notation. So times, now what's 10 to the 3rd times 10 to the 4th? 10 to the 7th. All right? So this product is just this. You see that? Y'all see it? Okay. But they want the answer not in scientific notation, but they want the answer in what? Standard form. So now let's go back and do what we just talked about. So how do you put this in standard form? Where's the decimal point understood to be? Right. And so how many zeros do I need? 7. Good. So 6 and how many zeros? 7? 1, 2, 3, 4, 5, 6, 7. And so this is your answer. So this is your work. So that's what I want to see. So I want to see the coefficient parts together and then the base 10s together. Okay? All right, now, you can always check your answer, though. Now, remember, this is the work. Use your calculator, check and see if what you got is correct. And all you do, guys, is this. You just say, what's what I'm doing? You're just saying, all right, 2 times 10 to the third times 3 times 10 to the what? 4, and then press equal, and this is what you get, which is this. So use this to check and see that this is correct. Okay? All right. But they do want to see the work. So this is what I want to see there. Because I know you can use your calculator. I know you can go from here to the answer in your calculator. But that wasn't the purpose of this section. The purpose of the section is to understand how to use the exponential rules with these. All right, so that was number 1. Let's look at number 2. Suppose I had 3.6 times 10 to the negative 6 power times 1.3 times 10 to the negative 3rd power. All right, so let's talk about the work. So you're gonna in parentheses, in the first parentheses, you're gonna say 3.6 times what? 1.3. Times, and then the base 10. So we 10 to what power? Times 10 to what power? All right. So that'll be your next step. Now, you have a calculator in front of you, so it's okay if you multiply the decimals using your calculator. So use your calculator because if you do it by hand, you're probably going to mess up at some point with multiplying these decimals. So just do this. So say 3.6 times 1.3. 3.6 times 1.3. And what do y'all get as your decimal? 4.68. So this is 4.68. Notice I use a calculator. That's fine. Times. All right, now when you multiply bases, we do those exponents. We do the exponents? Yeah. You add them. So what's negative 6 and a negative 3? All right, so that's where I'm at. Okay? And then you're almost done. My exponent, though, is what number? So I'm going to move the decimal point which way? To the left. So I'm going to go 1, and then how many zeros do I need? 8. Good. So the answer is going to be decimal 1, 2, 3, 4, 5, 6, 7, 8. And then what do I write? 4, 6, 8. So there's your answer. Okay? And check your work. Now the problem with using a calculator this time is that there's not enough digits in the display. There's not enough digits. So notice what happens. Watch. When you multiply this out, 3.6 times 10 to the negative 6 times 1.3 times 10 to the negative 3rd equal, you see what happened? It rounded off. So don't put that in as your answer, because that's an approximation. And it rounded off because that's as many digits as can be displayed. But that, you know, that's not the exact answer. This is the exact answer. So just be careful. Some of those you can use your calculator to see if what you did is correct. Others, you got to be careful. Now the zeros are correct. You can count the zeros here. How many zeros right here? Let's see. That's 1, 2, 3, 4, 5, 6, 7, 8. Let's see. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. All right. Number 3. Suppose you had 7.2 times 10 to the, oh, let me not do this one just yet. Let me make it a little bit simple. 2.6 times 10 to the 5th power, and then 2.5 times 10 to the negative 2nd power. All right, so your work. Let's talk about the work. What work are you going to show me? What's going to be that next step? 2.6 times 2.5, and then times, and then your base 10. So it'll be 10 to the 5th times 10 negative 2nd. All right, now use your calculator with the decimals. Don't make it difficult. Use your calculator with the decimals. So 2.6 times 2.5, 6.5. All right, and then when you multiply like bases with those exponents, that's 10 to what power? Third. But you want the answer in the worksheet, they want the answer in standard form. So that means you got to move the decimal point. How many places? Which way? To the right. So I'm going to need how many zeros? Not 3, 2. So 6, 5, and 2 zeros. And so there's your answer, 6,500. Now that you can check because it's going to show up in your display because it's not that many digits. So check it, 2.6 times 10 to the 5th times 2.5 times 10 to the negative 2nd. And notice you get 6,500. Okay? All right, now, the 3 we just did, those 3 we just did, when I multiplied the decimals, I already had how many digits in front of the decimal point? Just 1. So that's easy. That's the easy kind right here, where I only have 1 digit in front of the decimal automatically. So that's an easy kind. All right, let's do one where it's not just 1 digit. You can see what to do. It's not difficult. Just watch what I'm doing. All right, suppose we had suppose I had 7.3 times 10 to the negative 6 power times 2.6 times 10 to the negative 2nd power. Okay, so let's talk about the work. So the work, you're going to say 7.3 times what? 2.6, and then your bases, 10 to negative 6 times 10 to the negative 2, right? And on your calculator, what's 7.3 times 2.6? Use your calculator. Times 2.6, 18.98, is that correct? All right, and then that's going to be 10 to what power? Negative 8. All right. Okay, so now you want to write this in, well, actually, it's not that difficult. I mean, just move it. So I want to write this in standard form. So how many places am I going to move it? 8 to the left. So I already have how many digits in front of it? 2. So I need how many zeros? Yeah. So what's the answer? 1, 2, 3, 4, 5, 6, right? And then what goes here next? 1898. Now, put that in your calculator. Again, that's too many digits. It's not going to show up like that. Okay, any questions? That's all you do. All right, now let's do division. Number 5. Suppose you had 6 times 10 to the 4th power divided by 2 times 10 to the negative 2nd power. All right. So with the division part, you're going to divide. Remember how we divided the coefficients together and then we multiply the coefficients together, multiply the base 10s together? Same thing here. So you divide the coefficients, so you're going to say your work's going to be 6 divided by 2 times, and then you're going to say 10 to the 4th divided by what? 10 to the negative second. Not that difficult. That's what you do. And now you just simplify what 6 divided by 2 is. What's 6 divided by 2? 3. All right, when you divide like bases, what are those exponents? So you're going to say 4 subtract a negative 2, correct? Which is what? 6. So that's times 10 to what power? 6. So that's where I'm at. See what I did? 6 divided by 2. 10 to the 4 divided by 10 to the negative second is 10 to the 6th. But you want to write this in standard form. So the decimal points on this will be here. So that means I got to move it how many places? Which way? To the right. So I'm going to need 3 and how many zeros? 6. 1, 2, 3, 4, 5, 6. To get 3 million. All right, now be a little bit careful on your calculator. I want to show you what's going to happen with this. Here's probably what you're going to say. The numerator you're going to put in correctly. You're going to do that. So you're going to say 6 times 10 to the 4th, and then you're going to say divide by what? 2. And then you're going to say times 10 to the negative second. All right, just want to show you something. And you get what? 300, but that's not the answer. What's the answer? 3 million. So your error was in that denominator. So what you really, if you're going to use your calculator to check this, what you really need to do is put the numerator in parentheses and put the denominator in parentheses. So that's what you need to do. So you need to put the numerator in parentheses. So it's parentheses 6 times 10 to the 4th. Close the parentheses. Now say divide, and then put parentheses because you're dividing by this whole thing. So 2 times 10 to the negative second power. Close, and now you get 3 million. So what we did earlier was this. I'm going to show you what you were actually doing. So you're saying this. You're saying 6 times 10 to the 4th. Notice I'm not putting parentheses. Okay? Then you said divide by, right? You said divide by 2. That is true. I am dividing by 2. I am dividing by 2. But I'm also dividing by what number? 10 to the negative second. So if I divide again by 10 to the negative second, now I get what? 3 million. To be on the safe side, I would just use parentheses. It is a lot easier. Put parentheses, and then put that in your calculator. All right? Okay, let's look at number 6. Suppose you had 1.8 times 10 to the negative third power divided by 9 times 10 to the, let's say, second power. All right, what's going to be your work?
1.8.
Okay, times, and then 10 to the negative third divided by 10 squared. Okay, use your calculator for the decimal part. 1.8 divided by 9. 1.8 divided by 9 equal 0.2, right? Y'all agree? Okay. Here I'm dividing like bases. When I divide like bases, what do the exponents? So what's negative 3 subtract 2? And now negative 1. Negative 5, right? Negative 3 subtract 2 is negative 5. So that's times 10 to negative 5. All right, and now you're going to write the answer. So there's your work. This is your work. And now your answer. Okay. So I need to move the decimal point how many places? Which way? To the left. So how many zeros do I need? Okay, so I move it 1. Actually, how many zeros are you going to have? 5, really. Because that's a 0 right here. So you're going to say 0.5 zeros, right? 1, 2, 3, 4, 5. And then what digit? 2. Now, that's not a lot of digits, so you can put this in your calculator. So let's remember how to do this in your calculator. you need parentheses now. So you're going to say open parentheses 1.8 times 10 to the negative third, close the parentheses, divide by open parentheses, 9 times 10 to the second power, close, and then press equal. So notice what you get. You get this, which is this. Okay? All right, so any questions on scientific notation?
No.
All right, so that's that worksheet. So any questions on this? Just look at the back, make sure you can do this. That's all it is. Okay? All right, so that's part D. Now let me go ahead and give you part C.